Now we're going to go through the whole graphing process with this function. So we're going to find the domain, the x-intercepts, the vertical asymptotes, the holes if there are any, and the horizontal asymptote if there is one. And then we're going to sketch a graph with the help of the calculator. First of all, let's find the domain. For this, we're looking at what makes the denominator equal to 0. That would be -2. So this number has to be excluded from the domain. If we want to write our domain in interval notation, it would be from -∞ to -2, and then from -2 to infinity. Now let's look for the x-intercepts. This time, since we only have a constant on the top, if we took that and set it equal to 0, we'd get no solution. And that tells us that there are no x-intercepts. For vertical asymptotes, we can look at the number that was excluded from our domain. There's going to be a vertical asymptote there. The equation of our vertical asymptote is x equals -2. Since we didn't get any matching answers from the numerator or the denominator for what made each one 0, then there are no holes. And the last thing we can look at is our horizontal asymptote. If we look at the degree of our numerator, that's degree 0 because it's a constant. The degree of our denominator is 1. That means since the numerator has a smaller degree than the denominator, we automatically have a horizontal asymptote at y equals 0, which is the x-axis. So now we're ready to start sketching our graph. I'm going to put everything I can onto my sketch before I graph the function with my calculator. So I don't have any x-intercepts to plot. I do have a vertical asymptote at x equals -2. I'm going to draw that in as a dotted line. If this is -2, then here's my vertical asymptote, and I'm going to label it as x equals -2. I also have a horizontal asymptote, which is y equals 0, or the x-axis. I'm going to draw a dotted line over my x-axis, and I'm going to label that so I know that's my horizontal asymptote. At least this way, I know what to expect when I look at the graph on my calculator. When I put this into my calculator graph, I'm going to have to put parentheses around the denominator because there are two terms. And the calculator graph is going to verify what I already found, and it's also going to tell me about which direction the graph is going in different parts. So over here, I can see where my vertical asymptote is supposed to be at x equals -2. I'm seeing the behavior I would expect around a vertical asymptote. I'm also supposed to have a horizontal asymptote of y equals 0. I can see that on both ends of the graph, my graph is looking more and more like a horizontal line, and it's getting close to the x-axis. So that fits with what I found on paper. And now I can just draw this in. One thing to remember about this, since there were no x-intercepts, my graph is not going to cross the x-axis anywhere. I also can't cross the vertical asymptote. So I just need to be careful when I'm sketching this in and make sure that I don't go across that vertical asymptote. And also, since there are no x-intercepts, I'm not crossing the x-axis either. On this end, close to this vertical asymptote, my graph is going down towards -∞, and then as I go this way, out towards the right end, my graph is coming up towards the x-axis. Let's go through the whole process with this function. We're going to start by finding the domain. That's taking the denominator and setting it equal to 0. Since our denominator is just x, we already have an answer for the number that has to be excluded from the domain, and that is 0. If we want to write our domain in interval notation, it would be -∞ to 0 and 0 to infinity. Now let's look for x-intercepts. For this, we're taking our numerator and setting it equal to 0. This gives us a quadratic equation that we need to solve for x. We have lots of choices of how to solve this one. I'm going to use the square root method because there's no x term. I'm going to add 4 to both sides and then take the square root of both sides. I have to remember to do a plus or minus on this side. That gives me 2 different answers, either positive or negative 2. That means I have 2 x-intercepts for this graph, negative 2, 0 and positive 2, 0. Now let's think about the vertical asymptotes. I didn't get any numbers that matched when I found the zeros for my numerator that matched the zeros for my denominator. That means my vertical asymptote is automatically at the number that was excluded from my domain. It's automatically at x equals 0. And this is actually the same as the y-axis. Again, since I didn't get any numbers matching here and here, that means that there are no holes. And last of all, for my horizontal asymptote, the degree of the numerator, which is 2, the degree of the denominator, which is 1, and for this one, because the degree of the numerator is greater than the degree of the denominator, that means there's no horizontal asymptote. Before I start graphing this with my calculator, I'm going to add to my sketch everything that I just found. I'm going to add my 2 x-intercepts. These are 2 points that I can plot. I have negative 2, 0 and positive 2, 0. And I also have a vertical asymptote. That's the y-axis, so I'm going to draw a dotted line over the top of the y-axis. And I'm going to label it so that I know that's a vertical asymptote. There's no horizontal asymptote, so I'm not going to have a dotted horizontal line in here anywhere. Now I'm going to graph this with my calculator. I'm expecting to see these 2 x-intercepts and the behavior I would expect around a vertical asymptote around the y-axis. So yes, I've got x-intercepts at negative 2 and positive 2. On either side of the y-axis, my graph is either going up towards positive infinity or down towards negative infinity. And I didn't have a horizontal asymptote, so my end behavior, instead of looking like a horizontal line, on this end this is going down towards negative infinity. On this side my graph is going up towards positive infinity. So this all fits with what I found on paper. And now I can fill in the rest of this graph. I'm just trying to get the general shape of this. So here it's going up towards infinity as it gets close to that vertical asymptote. On this end it's going to go, on this side it's going to go down towards negative infinity as it gets close to the vertical asymptote. And then out here, after it crosses the x-axis, it's just going to go up and out.